Hello and welcome to my video, lesson 1.1 about proportional reasoning, which is basically just ratios and rates. So just to start, before we even get into these questions, just want to remind you guys about how they could show up. So in words, we could say A to B, so comparing apples and oranges, or comparing 3 to 2, you could be using numbers. You could use a colon instead of the word 2. That shows a ratio again. Or it could be a fraction. And any one of those are fine, but I'm going to tell you, if I see numbers, I put in a fraction. And that's because a fraction is the easiest to work with when it comes to math. We're actually going to do everything with a fraction anyways, so may as well change it to a fraction right away. Assuming b is not 0, but blah blah blah. That doesn't matter. Okay. It does matter, but it will never be 0 in our class, so we don't have to worry about it. Okay, there are 3 boys. So here's an example. There are 3 boys to every 2 girls in Mr. Drager's math class. If there are 10 girls, how many students are there in total? So this is how you're going to set it up every single time. No matter what ratio, no matter what rate, no matter what anything in this unit, it's pretty much this setup every time. Currency later on, changing unit conversion, all that stuff, it's always going to be the same. You're going to ask yourself, what do you want to know? Okay? And at this point, what do we want to know? We want to know how many students in total. But first, what we need to figure out is how many boys there are. Right? Because we know how many girls there are. We need to figure out how many boys there are. So we're going to ask ourselves the question, how many boys are there if there are 10 girls? So you're going to ask yourself, so what do you want to know? You're going to put on top, what do you know at the bottom? And then you're going to put the comparative ratio or fraction on the other side. And the way to do it is always to have the same on top as you had on top before. So we had on top boys. So we need to make sure we have boys on top. So 3 boys on top, and we had on the bottom girls. So we have to put 2 girls on the bottom. So just so you remember, 3 boys came from there, 2 girls came from there, 10 girls comes from there. So we want to know how many boys there are, and we know how many girls there are, and we know the ratio. So just making sure, like firing this home, whatever's on the bottom on one side needs to be on the bottom on the other side. Whatever's on top on one side needs to be on top on the other side. Okay, now that we have this, yes, we can do what we like to say in class, cross multiply. But instead, we're going to think about it more as opposite operators. So we have, if we have addition, the opposite operator is subtraction. If we have multiplication, opposite is division, and the opposite is also true. So if we have subtraction, addition, if we have division, it's multiplication. Okay, so those are opposites from each other, right? Opposite operators. So here we are dividing by 10. So instead of dividing, let's multiply by 10. So we're going to do it to both sides. So multiply by 10 over here, and multiply by 10 over here. What happens is, we'll cancel out this 10, so 10 divided by 10 is just 1, so it doesn't matter, it goes away. And then we'll multiply on the other side. So we are left with, let's put in blue here. We're left with 3 times by 10, divided by 2, and the question mark is on the other side. So 3 times 10 is 30, divided by 2 is 15. So how many boys are there in the class? Well, there are 15 boys. Okay, this is awesome. This is fantastic, but it is not the answer yet. We want to know how many students are there in total. In total. So what we need to do is then take the boys plus the 10 girls from before, And that gives us 25 students. So this is the setup every single time. You're going to set it up exactly like this. What is the unknown on top? What is the known below? Equals, and then you're going to have your ratio. Okay, let's prove it and do the same thing again. Even though it's a different type of question, it's going to be the exact same thing. Let's try it out now. So, I'll read out this question, and then the question we have to ask ourselves is, what is the unknown? Mr. Drager is driving on his way to school in the morning. He is driving at an average rate of 50 kilometers per hour. If he needs to go 10 kilometers, how long will it take him? I think that this distance is not very accurate to the size of our city, but anyways, it doesn't matter. So, we need to ask ourselves, what do we want to know? Well, we want to know the time. Okay? So it asks us how long. So what is the time taken? And how do we know what the unit is? Well, it's going to give us it over here. So time in hours. Okay? If he needs to go 10 kilometers, oh, so that's our known. He has to go 10 kilometers. It's known. How long will it take him? Well, we know that he's going 50 kilometers per hour. So, should I put 50 per hour like this? No, because what are you going to notice? We have hours here, and we have hours here. We need to switch those. We need to have hours on top. We had hours on top before. So, we are actually going 50 kilometers per hour. Watch this. Whoops, wrong button. Wrong thing. Okay, same unit on top. Same unit on the bottom. Now we have our setup. We want to know how much is the time, and we know that he has to go, I have to go 10 kilometers total, and I know the rate, which I have now put in. Okay, now let's try and do opposite operators. Well, we're dividing by 10 right now, so we need to multiply by 10. Multiply by 10. Whoops. And technically, we're multiplying by 10 kilometers too, which is important because, actually, I'll tell you why right now. It's important that we're multiplying by 10 kilometers because we can cross out the kilometers as well. And the kilometers over here, cross out with that kilometers. Just an interesting note there that our units can do the same thing. If you are ever interested in going further in chemistry, those sort of unit cancellations are vital. Okay, so now we're left with the time on this side, and on the other side we have 1 times 10, or just 10, divided by 50. Okay, so if we do, that's 10 divided by 50 is 1 over 5, or 0.2 hours. So it's the same process again. If you wanted to convert that into minutes, again, this would be in the unit conversion area, but you can just multiply it by, in this case, I'll just tell you, multiply it by 60. So let's write that here. Multiply by 60 minutes per hour. Actually, let's just write this like this. You'll notice hour on top, hour below, cancel, which is really nifty, really helpful. And then I'll just type that into my calculator because I'm lazy. which is not good, but anyways, 12 minutes. Hey, that's not bad. Maybe that is possible within the city. Okay, so I hope that this video helps you guys understand the basics of ratios and fractions and rates. Truly, this is how the rest of the unit basically all goes. Make sure that you set up with two fractions, and then you do opposite operators until you get to your answer. Hope this video helps, and good luck.